land cover and land use are currently changing at rates unprecedented in human history. And in order for us to manage and cope with these changes, we need to have the observations, the information, the data that allow us to understand what's going on the surface of the Earth where most of us live.
NASA's Landsat Data Continuity Mission, or LDCM, is set to lift off from the agency's West Coast launch site at Vandenberg Air Force Base, California, joining a long line of Landsat satellites and kicking off a new era in Earth observation. A joint effort between NASA and the U.S. Geological Survey, the Landsat program has provided a continuous view of Earth's surface and created a valuable archive of data for more than 40 years. The first Landsat launched in 1972 to begin the successful series. Each generation has improved its observational abilities, although one version, Landsat 6, did not reach orbit as planned.
2, 1, main engine start. And
the most recent mission, Landsat 7, took its place in orbit in 1999 and is still operating today. The Landsat Data Continuity Mission builds on this legacy of success.
We can find the scene or the image from that location from 1972 and go to the catalog of data from the LDCM, find that data acquired in 2013, and we can compare those two images directly, as well as all the images that have been collected in the interim.
Built by Orbital Sciences Corporation, the LDCM spacecraft features two advanced scientific instruments. The Operational Land Imager, or OLI, measures visible, near-infrared, and short-wave infrared wavelengths. The Thermal Infrared Sensor, or TIRS, tracks surface temperatures. Both instruments are designed to focus longer on a given area using what scientists call a push-broom approach.
Push-broom sensors have thousands of detectors that just image the Earth as the satellite passes over the surface of the Earth. The older Landsat satellites, Landsat 7, Landsat 5, use a whisk broom technology, which is many fewer detectors scanning back and forth with a mechanical scanner.
Both instruments will observe a 185-kilometer wide swath of land, moving from north to south on Earth's sunlit side. LDCM will collect data on a new area of land on every orbit. It will take 16 days to bring the entire surface into view. The data is received at one of 3 ground stations. Then, the U.S. Geological Survey's Earth Resources Observation Systems Data Center in Sioux Falls, South Dakota, processes and distributes the resulting images.
In 2008, they made a decision to begin distributing data at no cost, for free, to anybody who requested a scene. It enables people to do studies over time, over the 40-year history of the Landsat program, and over larger geographic areas.
To keep Landsat over water during the critical period of liftoff and ascent, managers selected Vandenberg Air Force Base as the mission's launch site. LDCM will be the first NASA mission launched at Space Launch Complex 3 since the agency's Terra satellite launched more than a dozen years ago. The 2-stage Atlas V rocket was built by United Launch Alliance. It's a perfect fit for NASA's need for the LDCM mission.
So we're taking this object that's 6,000 pounds, about the size of an SUV, and punching it into an orbit that's 350 miles up. So the Atlas is very capable of doing just that role, and that is why that vehicle was picked.
Like all missions, LDCM brought with it some special requirements to be considered during launch planning.
The LDCM spacecraft has a very stringent tip-off requirement. It can only be rotating so much when we separate. So the launch vehicle is going to do a compensation maneuver prior to that event.
And there was another challenge. The spacecraft has an onboard battery that needs to be charged before it separates from the Centaur.
We're going to go around the Earth an additional time and then separate them so they'll have their 60 minutes of sunlight on their solar array to charge their battery.
The spacecraft will have to go through a 3-month testing period before it's ready to begin normal mission operations. Then it will be renamed Landsat 8.
And then after checkout, we accept the observatory, and then we, in effect, hand over the keys to the U.S. Geological Survey to operate the observatory for the 5-year mission life.
Launch and mission teams have gathered at Vandenberg Air Force Base for final preparations leading up to liftoff.
You've got a lot of years of work put into that in those last 2 or 3 minutes, although quiescent and very still. It's kind of ominous. You can't wait to get there. And then the happiest moment is at T0 when you see the fire and smoke under the rocket and off it goes.
The wait is almost over. NASA's newest Earth-observing spacecraft soon will be in orbit, high overhead, ready to send back vital information about our own planet.
The data is used by thousands of users all over the world, and to me that's very rewarding to work with such a great team of people on a mission that really does affect people's lives.